Hi all, this is Yunus. Welcome to my channel. In this video, I want to explain the concept of containers using a non-technical example. Let's see how it goes. So what is my non-IT example? It is trees or plants. So just assume that you want to buy a plant and plant it on your backyard. So will you go and purchase a plant with naked root, something like this or like this? Or will you go for a complete package where you have your tree and you have a container or a pot on which the tree grows? Of course, it has soil inside that, and that soil has the required nutrients which is required for the growth of that particular plant. Which one will you go for? I'm sure you will go for this option, because if you purchase this plant with naked root and plant it on your backyard, there is a possibility that this plant may die because the soil where it is planted now doesn't have the required nutrients or water content, etc. So what is the relation of this plant to the container? We will explain that. So now let us get into our discussion on the IT part. If you take any operating system, let us take for example a Linux distribution like Ubuntu. A Linux operating system, any distribution it has two parts. The first layer, the base layer, is kernel, which is the heaviest part, which controls the hardware part. On top of which there is a comparatively smaller but important layer of binaries and libraries. Basically, it contains the basic utilities such as tar, telnet, ping, timeout, tracepath, tail, system control, touch, cat, so on and so forth. These basic utilities are used by the applications you write on top of this OS. So just like a tree extends its roots to the soil, your applications actually extends their body into these binaries and utilities. Knowingly or unknowingly, you will be using these small utilities in your application. Similar to a plant extending its roots into this layer, into the soil layer, you have your applications extending their body into this binaries layer. So that's why I have given this comparison here. This layer is like the binaries utilities layer and the trees are like applications. Now what is the problem with this is that assume that now you want to port one of your applications into a RHEL distribution. In many cases, your development environment may be Ubuntu environment, whereas your production environment is RHEL. So both RHEL and Ubuntu are Linux distributions. They have the same kernel, so there is no confusion there. But the second layer is different for these distributions. So app 1, which is already designed based on certain set of basic utilities here, if that app 1 is moved into RHEL, it may fail because it may not find the required libraries and binaries and utilities which it had used here that is actually missing in RHEL. So it may fail. To show you the difference between two Linux distributions, I have an Ubuntu machine here. This is Ubuntu. You can see with this command, you can see cat etc os release. You can see that Ubuntu is running here. So go to /bin and just do ls. And this is the set of utilities, or this is the set of binaries and libraries which we are talking about. For example, in Ubuntu, we have apt repository tool. If you do ls apt, you can see that it is present in Ubuntu. Now, let us go to another Linux distribution, which is Amazon Linux 2. So this is a cloud shell, and you can see cat etc os release says that it is Amazon Linux. So if you go to cd/bin and do ls, again, lot of binaries and utilities and libraries are there. And this is the binaries utilities layer which we are talking about. But if I do ls apt here, it doesn't exist. Instead of that, if I do ls yum, we usually use yum utility for installing software. So you can see that it is present. But if I do ls yum in Ubuntu, you can see that that is not present. So this is just one simple example. There are several such utilities where one utility is present in Ubuntu, but in Amazon Linux 2, that utility will not be there, but some equivalent, some other utility will be there. So this difference is there between two Linux distributions, and that will impact the way your application is functioning in Ubuntu versus the same application functioning in Amazon Linux 2, for example. So this is a real issue which the software engineers used to face, especially when the development team who develops their code in, say, for example, Ubuntu, and the code was tested, it is working fine, reviewed was done, the project manager has approved the deployment of it, and the development team will provide that code to the production team, the operations team. Operations team, when they deploy that application into their RHEL environment, it fails, and then the two teams will start fighting. So that was a real issue. So what was the solution to that? The solution to that actually lies in the same idea. When you buy a plant, you buy the plant along with all its dependencies, right? The soil and the nutrients, this pot. The pot is the container, and the dependency of the plant is this soil, right? The soil and its nutrients. So what the sellers do is the plant plus the soil is put into a container, which is the pot, and that container, entire container, is actually sold. A similar thing needs to be done for IT containers as well. So what needs to be done is this application 3 or whichever application 1 need to be combined with this binaries layer and then create a virtual container which contains both this application and this dependencies. Something like this, both application and the dependencies together in one single container, so that whatever utilities are required for this application to run, everything is part of this container. So the container will not fail. The container has everything at its custody. But then please note that the container doesn't include the kernel, right? The container doesn't include the kernel. Ideally, if you need to include all the dependencies together, then you need to include the kernel also, but kernel is very heavy. Kernel itself may be like 1.3 GB, etc. Whereas the container may be like 50 MB, 60 MB, etc. Because containers are lightweight, it can boot up very fast in few milliseconds. But if you include the kernel also along with it, that is a problem with virtual machine, right? A virtual machine may take a few minutes to boot up because it has the heavy kernel also along with it. So you don't want to include the kernel along with every container, because even for a small application you will have a very, very heavy kernel which will be part of it. So you don't want to do that. So you want these containers to use the kernel of the host server. Okay. So for example, in this case, host server has an RHEL OS. It has its kernel and it has its own binaries libraries layer, which your application doesn't want to use. It doesn't want to use this, but it wants to use the kernel. So who makes it possible? So that is made possible by Docker engine. So the Docker engine was introduced by Docker in 2013 when they came out with their containerization solution. So you can see that in a normal machine, you will not have the Docker engine layer. But here, if you are containerizing your applications, you need a Docker engine layer, which actually provides the platform for running your containers. It also provides the Docker CLI commands for creating your container image, for instantiating the container instances, for terminating them, to list all the containers, so on and so forth. And please note that in a machine, you can actually have multiple containers running, not just one container. Like this, say you have this container, another container, and both of them have their own dependencies layer, binaries layer, and both of them will use this kernel, but they will not use this binaries libraries here. So basically Docker engine makes it possible to virtualize the OS layer. So this is how the containers work, or this is how it is similar with a potted plant. Now before we close, I just want to mention one more important thing. Please note that what is the most important purpose of container is porting between platforms. Earlier, porting a software from one platform to other platform was very difficult. It created a lot of issues and people used to fight, right? But now with containers, it is very easy to port your software, your application from one platform to the other platform. And there is also a story behind this name container. See, in the shipping industry, in the 1950s, they standardized the container sizes or the containers, shipping containers. So now the same shipping container can be lifted from a ship and shifted onto the train, or it can be lifted from the ship and shifted onto a truck. Your train, trucks, and the ships are designed to accommodate this standardized container. And that was another reason why the IT containers got its name, because that is also about porting, or that is also about making the process of porting software easier. And this standardizing containers actually improved the efficiency of shipping industry manifold. Similarly, the IT containers actually has improved the efficiency of IT systems as well. Okay, so that's it about this video. I hope you enjoyed it. Let me know your comments. I'll come back with more useful videos. Please consider subscribing to my channel. Thank you. Bye.